Hi everyone, welcome back to Java 1 for All. In this video, we are going to see how we can override and provide implementation for the hash code. Pretty straightforward. Since the equals is in the object class, the hash code is like equals brother. We also have it in the object class. So we just press Ctrl O and we are going to override the hash code. So basically, if you go up all the way to the object class, you will see this public native int hash code. Basically, when you have this native, it means that the implementation for this code was written in a different language. I'm not sure exactly which one, but probably it was C or C++. But in any case, this is what the native means. Now, we are overriding and we have to provide the implementation for the hash code. But there are some rules. The same way we have some rules here when providing the equals implementation, we also have some rules when we are providing the hash code implementation. So the rules are pretty straightforward. So for example, if you have x dot equals y true, this means that the y dot hash code should be equal to x dot hash code. And why is that? If we go back to our example and we say that we are looking, for example, for Dirk, of course, if the object is Dirk and we are looking for Dirk, it means that the hash code of Dirk should be the same. That's why we have this rule. So if Dirk is Dirk, then the hash code of Dirk should be the hash code of Dirk. Then we have another rule, y dot hash code equals to x dot hash code. It doesn't mean that y dot equals x should be true. And why is that? If we go back to our example and we get the hashes of Alex and Dirk, both of them will have the hash code 42, but the equals of Alex and Dirk will return false. That's why it doesn't mean that the equals will return true. And of course, if you have x equals y false, you don't have to worry about the hash code. But y dot hash code is different than x dot hash code. This means that x dot equals y should be false. Right here, should be false. And that's why it's important for you to provide a hash code implementation that is using the same object as you have in your vehicles. So in your vehicles, you are telling Java two objects are the same if the serial number are the same. And in the hash code, you are going to use the same serial number to generate the hash. Otherwise, this last condition may not be fulfilled. Fortunately for us, we don't have to think a lot about the hash code implementation because we can rely on Java. For example, we want to tell that two objects are equal if the serial numbers are equal. And here, since serial number is a string and we are using serial number dot equals, we can also return serial number dot hash code. This means I'm relying on the hash code from the string class that already has a implementation ready to be used. Now, as you can see here, we have this if. And this if is pretty important. In this case, it's returning, if you go back all the way, for example, int h equals hash. If you go to the declaration, hash is 0. Basically, we have to provide the same because if serial number, that's in our case here, null, and I call null.hashCode, boom, you will have null pointer exception. So we are going to provide here a quick ternary operation. So if serial number is null, just return 0. Otherwise, return serial number.hashCode. So this way, using the same value that I have in my equals in my hashCode, I'm fulfilling this condition. Okay, now let's, I think it's time for us to start working with collections and see equals and hashCode in action. So let's move on, and in the next video we are going to work with collections. See you there, bye.